So I wanted to do a very quick example. So okay. So here's an example. So find a polynomial of degree n less than or equal to 2 that passes through the points 1, 1, negative 1, 2, and 0, 3. Okay, so therefore we have the xi's. So this is actually rather simple. So we get 1, negative 1, 2, and then we're going to get 1, 2, 3. Something's wrong. 1, negative 1, 0. And then 1, 2, 3. Okay. So this is actually rather easy. For us, this is going to be P2 of X. So we'll leave out the first one. So that'll be X minus a negative 1. So that'll be X plus 1 times X minus 0 divided by 1 minus negative 1 and 1 minus 0. And that gets multiplied by the first yi, which is 1. And then we'll leave out the second one. So we'll have X minus 1 times X minus 0. And that'll be divided by 1, negative 1 minus 1, negative 1 minus 0. And that'll be times the second value, which is 2. And now we're going to leave out the 0. So we'll get X minus 1 times X minus negative 1 divided by 0 minus 1 and 0 minus negative 1 times the third value of 3. So in the denominator, I get a 2. So this turns out to be 1/2. I'm going to take that x. So I'm going to get x squared plus x. Then in the second one, I have positive 2. Let me see, what's in the denominator? I think I wrote that wrong. Oh, the 2's cancel. Okay, so this 2 and that 2 cancel. So I just get x squared minus x for the second term. And for the third term, I have minus 1 in the denominator. So that's going to make this a negative 3 times x squared minus 1. So this then becomes P2 of x. Turns out to be minus 3/2 or negative 3/2 x squared minus 1/2 x plus 3. Now, as you can see, these values are, the X values are at -1, 0, and 1. So I can use this thing. So now if I want to find P2 of a half, I can interpolate what P2 of a half would be, because 1/2 is inside the domain of the smallest to the largest value of X. So I would just get -3/2. I'd take 1/2 squared, so that would give me 1/4. I would have -1/2 times a half, which would give me another 1/4. And then I would have +3. And so this is easily computable. This is -3/8 minus 1/4 +3. So 19/8. So that's what I would expect my interpolated value. Since I don't know what f, the actual f function is, I can't find f of a half, but I can use this to give me what I would think f of 1/2 would be. So as you can see, if I were to just draw, let me go in here and just do something of this form. I don't want to do that. A. Okay, so I had the 0.11. So here's the point 0, 3, 0, 1, 2, 3. So here's 0, 3, and then -1, 2. So -1, 2 would be there. And then 1, 1 would be here. So just using the polynomial that goes through there, I would get that if I did 1/2, it would be about 2 3/8. So I would expect the value at a half to be right here. Okay. All right, so that's how we would use that. And that looks to be pretty good if I assume my data looks like that. Okay, so what is the error for this interpolating polynomial? All right. So our error for the interpolating polynomial is as follows. So E of X, that is not what I want. Oh, that is right. Actually, I think I'm going to do the error last. I'm going to do the next topic and then we'll do the errors all at the same time. Okay. So let's now do what we call the Newton divided difference polynomial. Okay, so the Newton divided difference polynomial. This one I always felt when I was learning it was somewhat confusing. As I said to Yi Bing before, some of the time it's interesting how you have to teach some of the things that when you were a student were like, oh my God, that was so incredibly hard, but you actually learn it. Okay, so we want to find our first polynomial to be P1 of X. So let's say P1 of X is A naught plus A1 times X minus X naught. So X naught is the first value, as if we just had the one, trying to draw a polynomial from a point X, a line from a point X to a point X naught. Okay. P2 of X would then be A naught plus A1 times X minus X naught plus A2 times X minus X naught times X minus X1. P3 of X would be A naught plus A1 times X minus X naught plus A2 times X minus X naught, X minus X1 plus A3 times X minus X naught, X minus X1 times X minus X2. Now, the first thing you should notice about this as an advantage over the Lagrange interpolating polynomial is that for this method, knowing P1 helps me find P2. Whereas in the other one, just knowing the polynomial for points something going only through 2 points did not help me at all when I added a third point. But this one, the Newton divided difference polynomial, each time I add a point, I add a new component to the degree of the polynomial, but I get to use what was there before. Okay, so I will keep doing this. And I get all the way down to Pn of X is obviously going to be the one before, Pn minus 1 of X, plus a last term An, X minus X naught, X minus X1, and then I'm going to multiply it times X minus Xn. So as you can see, Pn of X is obtained from Pn minus 1 of X. So that is very nice. Okay. All right. So how do we calculate these coefficients, A naught through An? Okay. So the first thing we want to do is calculate the coefficients. Okay. So in order to calculate the coefficients, we're going to start off with P1 of X is equal to A0 plus A1 times X minus X0. Okay, now we know that Y0 is F of X0. So again, we are given set of points xi, yi, I equals 0 to n. Okay, so Y0 has to be F is F of X0. And if I put in P1, which has to correspond to the polynomial P1 of X0, I just get A0. Okay, so Y0 is simply A0. Now Y1 is F of X1, but that's P1 of X1. And P1 of X1 is A0 plus A1 times X1 minus X0. So now I get two things. The first thing I get is that A0 is F at X0. That's my Y0. And A1 is going to be F of X1 minus F minus A0, which is F of X0 divided by X1 minus X0. And we're going to call that in brackets F of X0, X1. And this is the first divided difference. Okay, so how did we get that? Again, if you just solve for A1, you'll get A1 is equal to Y1 minus A0, but Y1 is F of X1 and A0 is F of X0. So you get that. Okay, then what we will do is we find A2. Okay. So A2 turns out to be well, A2 is going to be what we call, it's going to take F, the Newton divided difference of X1 and X2, and subtract the Newton divided difference of X0 and X1. And then we're going to divide by the difference between the two of them, which is X2 minus X0. So what is that? Let's just compute that for a moment. Okay. So this A2 is actually F of X2. Okay. So no, it's not. It's not F of X2. This is, so if I just compute this for a minute, F of X, we already know what F of X0 x1 is. So what is f of x2, x1, x2? Well, f of x1, x2 is f of x2 minus f of x1 divide, this is driving me nuts. Oh my God. Divided by x2 minus x1 minus f of x1 minus f of x naught. X1 minus x naught. And then that whole thing hang on one second. I'm wondering if this is, okay, so I forgot to restart the video. So let me go back just quickly and say here how we then compute this table. So this table contains all of the divided differences for a problem with 5 points, x0 through x4. So we find the divided differences. Okay. All right, so now let's do a full example. All right, so here are the points. So here's the example. All right, so we're going to get these points. 0, 1. We get 1, 1.3. We get 2, 1.6. We get 3, 1.9. And we get 4, 2.2. All right. So we're going to make this table again. So here's the table for our example. So the table for our example is we have xi and so our xi's are 1.0, skip some space guys, 1.3, skip some space, 1.6, skip some space, 1.9, and then these are not lined up. That is ridiculous. 1.6, 1.9, and then 2.2. Okay, so now you need to find the first divided difference. So we need f of xi. And we said this one was, oh, I gave you the wrong points. These are not the points. I will give them this way. These are, let me give you this. So this value is the first F value is 0.765 1977. That's its F value. I apologize. This one is 0.6200860. Then the next one is 0.455402. The next F value is 0.281886. And then the last one is 0.1103623. Okay. All righty. So now I need to do the difference between that. Okay, so this next one, which is now the first divided difference, is to take f of xi minus 1 and xi. So this is the first divided difference. So that is to take x1 minus x0. This is number 1. So I'm going to take x1, f of x1 minus f of x0 over x1 minus x0. So therefore, I get here negative 0.4837057. Then I'm going to take f of x2 minus f of x1 over x2 minus x1, and I get negative 0.5489,460. Okay. Then I'm going to take x3 minus x2, f of x3 minus f of x2 over x3 minus x2, and I get negative 0.5786,120. And then the last one is negative 0.5715,210. Okay, so that's the first divided difference. So now I'm going to take, for the divided difference, I'm going to take this one minus this one over this minus that. Does everybody see how that works? So in order to get this next one right here, I'll do that again. So this one right here, I took this minus this divided by this minus that. So that was how I got that first path. Now for this one right here that I'm getting ready to write, which is negative 1087339. So this one, how did I compute this one? Well, I take this one, that's that Newton divided difference at the second one, minus this Newton divided difference, divided by x2 minus x0. Okay. The next one here, which is negative 0.0494433. That one I took this value minus this value, divided by 1.9 minus 1.3. And then this next one, I'm going to get 0.0118183. Okay, I only have two more, guys. Woo, getting down to the wire. So I did the first divided difference, the second divided difference. This one is f of x minus 2, xi minus 2, xi minus 1, and xi. Okay, so that's the second divided difference. First, second. Okay, third divided difference is f of xi minus 3, xi minus 2, xi minus 1, and xi. So this is the third divided difference. Okay, and there are only two of those. This one is 0. I should be over here. 0. Oh, nope, I should be in the same line as this other one. So this is 0.0658784. And then down here, this one is 0.0680685. Okay, how did I get this value? So how did I get this one? I took this value, this divided difference minus this divided difference, and then that is over 1.9 minus 1.1 minus 1.0. Okay, so I traced it back. Okay, one last one. So we only have one last one. And that is the fourth divided difference. And this one is f of xi minus 4 all the way up to xi. So this is the fourth one. And there's only one of those. And that is on the same line as this one, which is 0.0018251. Okay, woo, that takes some work, but the computer does this very quickly. Okay, so now I have all the Newton divided differences. Okay, so the numbers that I need are these. So here are my coefficients. This one, let's use the green. So I need, that is my A0. Then this is my A1. Then this is my A2. Then this is my A3. And that last value is my A4. Okay. So when I put it together, I get P4 of X is the first number, 0.7651977. That's A0. Then I have plus A1, but A1 is negative. So I get A1 is negative 0.7651977. 483.7057, and that is x minus x naught. Well, x naught was 1.0. Then my next term is my A2, which is minus 0.1087339. And that is x minus x1, which is 1.0, and x minus x naught, which is 1.0, and x minus x1, which is 1.3. Okay, then my next term is plus A0, A1, A2, so this is A3. A3 is plus 0.0658784, and this is x minus x minus 1, not 1.0, times x minus 1.3 times x minus the next one, which was 1.6. And the last term, which is to add on A4, A4 is 0.0018251. And that is x minus 1.0 times x minus 1.3 times x minus 1.6 times x minus 1.9. And that is the Newton divided difference polynomial going through the 5 points. Okay. Any questions? Okay. This one is actually rather difficult to implement, so I'm going to go through it. I'll start the implementation. Okay, so what we'll do is we're going to store the divided differences in an array. Okay, and I'm going to call the array D, K, J. Okay. So in DKJ, I'm going to store F of X, K minus J, X, K minus J plus 1, all the way up to XK. And here J is less than or equal to K. And so in a sense, what it really is that D of KJ literally turns out to be D of K, J minus 1, minus D of K minus 1, J minus 1. And that whole thing gets divided by XK minus XK minus J. Okay. So for an example, D, oh, we got 2 minutes. Not gonna have time, not gonna have time, not gonna have time. Okay, D52 is simply F at x3, x4, x5. So D52 is really D51 minus D41 all over x5 minus x3. So that's what we were calculating. So this is simply the Newton divided difference of x4, x5 minus F of x3, x4 divided by x5 minus x3. Okay. All right, I'll finish this on Tuesday, and on Wednesday, I will give you the take-home exam. Okay, and you can turn it in the next day. I'll put it up. All right. Any questions?